Now notice that they have an expression after sine. So I'm going to put that in a box, get the sine of this expression by itself. So I divide both sides by 2. And so then sine of this expression is root 2 over 2. Well, sine is positive in the first and second quadrants. Root 2 over 2 is that 45-degree or pi over 4 angle. Pi over 4, 2 pi over 4, 3 pi over 4. And again, plus 2 pi k. So this part doesn't change. But the portion after sine is this whole expression. So I write that whole expression here, because sine of that expression is still going to be root 2 over 2. And once I solve for that expression, let's now get x by itself. Let's add pi over 8 to both sides. Well, pi over 4 is 2 pi over 8, plus 1 pi over 8 is 3 pi over 8, and 3 pi over 4 is 6 pi over 8. Multiplying top and bottom by 2, add pi over 8 to both sides, then 6 pi over 8 becomes 7 pi over 8, and both are plus 2 pi k. Because adding pi over 8 doesn't change the 2 pi k. And there's the general solution. Don't forget, I'm going to solve for the expression first, and then I'm going to solve for x. And as usual, we have to define k, and k can only be an integer. So this is tangent squared of this expression. To get rid of the squared, I root both sides. A students, don't forget the plus or minus. And tangent is 1, right? When x and y are the same. So that's again pi over 4. But since it's plus or minus, 3 pi over 4, 5 pi over 4, 7 pi over 4. And if I go to 8 pi over 4 just to double check, yep, that's 2 pi. That's where that should be. So then here's that expression. And again, because it's plus or minus, and it's pi over 4 or 45 degrees, I can take this one angle and add pi over 2, pi over 2, pi over 2, pi over 2, over and over and over again. I'm going to distribute the pi over 12, and I get to here. So this is 2 pi over 12, and this is 3 pi over 12 to get a common denominator. If I add the 2 pi over 12 to the 3 pi over 12, I get the 5 pi over 12. Now to get t by itself, I have to multiply both sides by 12 over pi. And on the right side, I have to distribute. So that's 1, that's 1, so t is left. Distribute here, the pi's are gone, and the 12's are gone, leaving 5. If I distribute here, 2 goes into 12 6 times, the pi's are gone, and I have 6k. So here is our general solution. This time they want t, which is what we're solving for, to be between negative 12 and 24. So if I start here in the middle, I plug in 0, I get 5. If I plug in negative 1 for k, I get negative 1, and that's still between negative 12 and 24. If I plug in negative 2 for k, that's going to be negative 12, plus 5 is negative 7, and that's still in between these two. But if I plug in negative 3, This will become negative 18 plus 5 is negative 13, and that's too negative or too small. Going the other way, I plug in 1 for k, I get 11, that's in here. I plug in 2, this is 12 plus 5, I get 17, that's in here. I plug in 3, 3 times 6 is 18, plus 5 is 23, that's in here. I plug in 4, and it's too big. So then the k values, the t values they want are from here to here, the t values, that's the goal. The k is what we're using to get to the t.